Alright, so I've had some questions about completing the square. So I'm going to look at completing the square in the three different forms that we've seen it. So first I'm going to look at the circle. And I'll do this as a short video of looking at completing the square for a circle. And then I will do the same with parabolas and the different forms of a parabola if it's in an equation or in functional form. So what makes me know this is a circle is if I look at my powers and my second power terms of x and y, their coefficient are both positive and exactly the same. In fact, if there was a number in front of these and it was the same number, we would divide it out to make sure that they would have 1 in front of them, but it has to be the exact same coefficient. And so this is a circle, and there is some form to the circle. And so what I want to find is, I really like when I have my circles in this form, because I have my center at h, k, and the radius is r. So if I can convert this to look like this, I'll be in the place that I need to be. Now this is done by completing the square. We need to turn the y component into a perfect square and the x component into the perfect square. So I want to rewrite this with some spacing between the x and the y's. Squared minus 6x, give a little bit of space here, plus y squared minus 8y. And what I want to do is to find something that makes this a perfect square. What do perfect squares look like? If I were to multiply this back out, and I'm just going to focus on the one term here, the x minus h squared. So x minus h squared is equal to x minus h times x minus h, which is x squared minus 2hx plus h squared. Notice the information here. 2h is in this middle term. So in this term here, this term with the single power of y or x, I have information about h. In fact, this middle term, half of it will give me what h is. So I take half of this middle term. So x squared minus 6x. Well, what's half of 6? It's 3. So 3 is going to tell me what h is. But I need h squared. So I take half of 6, and I'll write this over here. 6 divided by 2 equals 3. And then I square that. So 3 squared equals 9. And so I need to add 9 to this to make this portion a perfect square. But in doing that, this no longer keeps the equality the same. Right? I've added 9 to one side, so I also have to add 9 to the other side. Let me actually move a little space over to my side work over there. And so the negative 9 plus 9. Well, I now need to do the same thing for the terms involving y. So I'll bring down my y squared minus 8y. Well, half of negative 8 is 4. So 8 divided by 2 equals 4. And 4 squared is 16. So I need to add 16 to this side, and whatever I do to one side, I do to the other. Alright, so I'm going to focus on this. I have made this a perfect square. I forced it to be a perfect square by finding that value of h. So I can revert it back to the term. In fact, whatever I half that middle term is what my h is going to be. And I did the same thing over here. I forced this to be a perfect square. And what you'll want to do is check for yourself. If you square this, you should get the x squared minus 6x plus 9. And if you square this, you should get the y squared minus 8y plus 16. And then I'll grab my terms together here. So negative 9 and positive 9 cancel out, leaving me with 16. And so I have a circle at 3, 4 for the center with a radius of square root of 16, or 4. And so I used complete the square to transform from this form into this form, because visually the information I needed was in places where I could pull out points and radial values. All right, I'll continue to work on the complete the squares as I'll do a video to see how this looks with parabolas.